All right, guys. So obviously I'm not here. A while back I had signed up for a technology workshop. It's an advanced technology workshop, and it kind of crept up on me. I didn't realize it was today. So even though I'm not here, I'm still going to show you a lesson. It's your 8.6 notes, but it's actually the wrong title. The 8.6 notes are actually the 8.4 notes. You'll also notice that I don't have the bell work showing because I don't want it up on YouTube since it's the semester final. But I am going to refresh your memory on some stuff that you should know up to this point. We talked about exponentials. I have some problems that are already worked out because I don't want to waste time working them out. But there's three scenarios here. Scenario number one, that's where the bases already match. You can cross them out, solve what's left. Scenario number two is the scenario where bases don't match. So the strategy is to change the big one to make it match the small one, and then once they match, you can cancel them out and solve it like normal. Just don't forget, if something already has an exponent and you put another exponent up there, such as this 3 right here, you have to put the stuff that was already up there in parentheses and distribute that new exponent. Then scenario number three is the one where the 27 cannot turn into the 9. So what you would have to do is you would have to change both of them. And you can see in this problem, I didn't finish solving it because at this point in your math career, you should be able to solve that question yourself. So that was just a refresher because we're going to talk about what happens if the bases don't match and you cannot make them match. So basically all you have to do is take the log of both sides, and then you can use some of the log properties to simplify them. Now, because we went out of sequence, there's some properties that you don't know about yet. So I'm just going to show them to you because they're actually not that hard. The one that we'll be using the most is the one where you're allowed to switch an exponent to the coefficient of the log. So just real quick, it looks something like this. If you have a log of base whatever, I don't care, and we'll say a, and we'll say this is to the x power, there's a property that says you can actually move this to the front. So it would actually turn into x times the log base b of a. So we're going to utilize that today since looks like there's a bunch of exponents over here. So if you look at the examples that we have, I've got 7 and 5. Obviously, I can't change a 7 to a 5, and I also cannot change a 5. So what we would have to do is we just have to take the log of both sides. Actually, I'll do it on the next line. So we'll have to take the log of 7 to the 3x equals log of 5. And because of the rule that I just showed you up above, we would have to take that exponent and just move it to the front. So this would become 3x times log 7 equals log 5. Don't forget, these logs, they're just decimals. So all that means is if I want to get the x by itself, I would just have to divide the whole thing by log 7. So I divide this by log 7. The logs cross out, so I'm left with 3x equals log 5 over log 7. And then I just have to divide this by 3. And that's all calculator work. So since it just says log, I just use the regular log button. I don't have to change the base or anything. So log 5, oops, let me divide this. I got log 5 divided by log 7 divided by 3. And it's a decimal. And you're going to see there are a lot of decimal answers here. So I got 0.276. Next one. If it has an e in it, it's probably better just to use an ln. So I'm going to take the natural log of both sides. E to the negative x equals ln of 1. Same rule as before, though. This negative x can move to the front. So we have negative x times the natural log of e equals natural log of 1. Now this part's even better because the natural log of e, there's a rule that says that the natural log of e is it's actually just 1. So if you type in your calculator ln, second ln, and then put in a 1, you'll see that the answer is 1. So we actually don't have to divide this at all. We can just kind of ignore the natural log of e. Since it's turning into 1, and 1 times negative x is negative x. So we have negative x equals natural log of 1. And so I just need to divide by negative 1. So the natural log of 1 divided by negative 1 is equal to 0. And I already kind of knew that because there's another property that says the natural log of 1 is 0. So natural log of e is 1, natural log of 1 is 0. You don't have to really memorize those because you can just type them in the calculator anyway, so that's not that big a deal. Third one, it's got an e in it again, so we're going to use natural log of e to the x minus 6 equals natural log of 150. So that way we can move this entire quantity that's in the exponent to the front. So we have x minus 6, natural log of e, natural log of 150. And just like before, natural log of e is the same as 1. So you could just kind of ignore it because 1 times anything is whatever the other stuff is. So we just have x minus 6 equals natural log of 150. And so to get x by itself, we would just have to add 6. So x equals, actually I'll type that in the calculator, natural log 150 and then plus 6 to that. So it ends up being 11.011. Let's see, we got some more on the next page. On the next page, you can see that there's some extra stuff around the base that has the exponent. So the only catch here is you have to isolate it first. So I can't have that 2 there, so I'm going to subtract the 2 first. So that gives me negative 30 equals negative 10 to the x. Also, I don't want to have that, that negative there, so I'm just going to also divide this by negative 1. So I have 10 to the x equals 30, and now I can do what I did on the other page. Again, I can't turn a 30 into a 10, so I have to take the log of both sides. So I can do log base of 10, log of 30, bring the x out to the front. If I have times log of 10 equals log of 30, oops, I could just divide by log of 10, and I could divide this by log of 10. So that's all calculator work again, log 30 divided by log 10. It ends up being the same thing as whatever log 30 is because log base 10 of 10 is also equal to 1. Anytime the base of your log matches the number that you're taking the log of, they just kind of cancel each other. So I don't know what's happening to my board here. It's like it's running out of ink. Next one, it's got, so x minus 2 is the exponent, and it belongs to the base of 0.3. So I actually have to divide the 5. I have to get that base all by itself. X minus 2 equals 6. And then I can go ahead and take the regular log of both sides. So that lets me move the x minus 2 to the front. So I have log of 0.3 equals log of 6. Then I need to get the x minus 2 by itself. Since these are being multiplied, I can divide it out. Because remember, log of anything is just a decimal. So I have log 0.3, so these cross out. So log 6 over log 0.3. Then I just have to add 2 to both sides. And that's all calculator work from there. So log 6 divided by log 0.3. Actually, I'm going to put that in parentheses. Log 0.3. And then add 2. Hang on a second. Log 6 divided by log 0.3. So I end up with 0.512. The third one is just like the first one on this page, kind of like this 2 right here. So you still have to just get rid of that 2 by subtracting it. So that's 8. So I have 3 to the 2x minus 3. And then I'm going to have to log both sides. So I have log of 3, and then log of 8. And then in the same step, I'm going to just go ahead and put the 2x minus 3 in the front. So I can divide the log of 3, and I have 2x minus 3 equals whatever that decimal is, log 8 over log 3. So I would have to add 3 to it, and then divide the result by 2. Let me see what I get. Log 8 divided by log 3 plus 3. It's about 4.893. And then just divide that by 2. So I get x equals 2.446, roughly. And so that's how you do it if you have the bases that don't turn into each other. You have to take the log of both sides unless there's an e. When there's an e, you can just use ln because that makes everything easier. And then if you have extra stuff that's attached to your base, like the extra 2 in the first example up here, or the 5 that's being multiplied like the second example, you have to isolate the base first before you can take the log of both sides. So your assignment, just do the whole thing. See you when I get back. Oh, and also I forgot. I'll also have the answer key posted on the wall. So no reason for not figuring out how to do this stuff. See you tomorrow.